Our planet may be under threat. One day, a natural or man-made disaster could make life on Earth impossible. If we can't live here, where will we go? I'm Dr. Basil Singer, physicist and robot builder. I'm on a mission to find a new home for the human race.
Imagine doing this with a spacesuit on.
I'll look at the best science on Earth to work out where in space we could live, and what dangers and adventures lie ahead for the space pioneers. 2250, a journey dreamed about for centuries, beyond the solar system. Our first voyage to the stars. Traveling to a new solar system is an extraordinary challenge. It's a journey of 100 trillion miles that could take tens of thousands of years. Wow! But there's a unique reason for making such an unimaginably difficult journey.
Don't look down.
You have to go outside our solar system to find another planet that's like our own. A planet that can be home for the human race. We're searching for a second Earth.
In our Milky Way galaxy that contains 200 billion stars, all the stars you see at night, I suspect that something like half of them have their own planetary system.
There are just 8 planets in our solar system. We can live on them, but they're not much like home. But outside our solar system, it's a different story. Planets around other stars are called exoplanets. And over 300 of these mysterious worlds have been identified.
I think we're going to find extrasolar planets that have the size and mass of the Earth far more diverse than our imaginations can conjure.
But there's a problem for my mission. The search is in its early days. And so far, very few could be a new Earth. This is my data command center, where I'm pulling together everything I need to plan my mission. Going to another solar system means completely rethinking space travel. The nearest star system, Alpha Centauri, is more than 4 light-years away. That's over 25 trillion miles.
Ignition, we have ignition, we have...
Relying on old-school rocket technology would be a massive mistake, because it would take 70,000 years to get there.
If we have to colonize space using rockets, I think we're in trouble. The amount that it costs could run every country on the planet broke.
Instead of using rockets, explorers of the future will ride into orbit on an extraordinary invention. It's a kind of elevator into space. It's a mind-boggling idea. First, launch a satellite into orbit, 22,000 miles above Earth. Lower a cable and attach it to a platform on the ground. And then send laser-powered elevator cars with people and equipment up the cable. A team in Kansas is bringing the idea down to Earth. Brian Turner is the captain of the Kansas City Space Pirates. He's going to show me exactly how a space elevator will work.
Trying to explain the space elevator helps if you have something visual. So what we've done here is we've taken a beach ball-sized globe here.
Yeah.
Tied ourselves a string onto it at about the right spot, and we're going to spin this thing up, and it'll demonstrate how the space elevator is expected to work.
Right, if this was real and that was Earth, what is this attached to?
This will be held out by the spinning of the Earth, okay? Just like you can keep a yo-yo over your head by spinning it around.
Yeah.
Okay, the spinning of the Earth keeps this up by just having a weight on the end of it. So we've got a mock weight sitting here.
What weight would you have in real life, though? A big satellite or something?
Yes.
NASA wants to make space elevators a reality. They've invited the Space Pirates and 8 other teams to take part in a competition.
Right, what's the prize money this year?
$2 million.
No way.
I'm really psyched. There we go. Now we need to stand back a little more. Too fast. Slow down. Slow down.
It's amazing to think that you really can scale this up to full Earth size, with the tether held vertical by being tied to a huge satellite in space.
I've read about space elevators in science fiction, but I didn't know anyone was taking it seriously.
Well, you've just met a real, honest-to-goodness, live mad scientist.
But many scientists think space elevators are the only sane way to get into space. Brian's elevator cable is made out of rope. Scaling it up to 22,000 miles is going to be a real challenge.
Well done. Space exploration isn't easy, is it?
One way.
One way.
A working space elevator needs a much stronger, longer cable. Finding a material tough enough has kept this idea firmly rooted in science fiction, until now. Carbon nanotubes could be the answer. 30 times stronger than steel, but incredibly lightweight. Nanotubes are so much more robust than any existing material that they could transform space elevators into science fact.
That's why we've got all this new excitement, is it looks like carbon nanotubes are going to be able to pull this off for us. All right, let's give it a try.
Okay, which way? Is it down?
I don't know, just kind of bump each button, and when it looks like it's moving, there we go, we're moving.
Hey!
There we go, and it's gonna jump up. And again, it got caught on the way.
For my pioneers, a space elevator will be the most efficient way to escape Earth's gravity.
How big do you need it?
5 feet.
5 foot.
Now we know it's possible to make the cable out of carbon nanotubes. The Space Pirates can get on with perfecting their design for the elevator car.
Feeling confident?
I'm feeling confident.
Come on then. Come on. Wow. That's properly fast.
Yes.
I'm impressed.
It's a small step towards a space elevator that can carry heavy loads into space again and again.
Okay, give it a try.
You trust me?
And that's just as well. The Exoplanet mission will be the largest ever attempted by mankind, requiring millions of tons of equipment to be transported into orbit so that giant vehicles can be constructed in space.
Practice makes perfect.
The Exoplanet crew fly up the cable, reaching the top 22,000 miles above Earth. Their waiting mothership is a sweet sight. The shuttle joins the mothership. No room for error at the start of man's longest ever journey. My pioneers are heading out of our solar system and across trillions of miles of interstellar space. They're searching for a second Earth orbiting a distant star. A place where humans could not just survive, but live comfortably. How do you pick the right planet when they're so small and such a long way away?
We'll have to choose carefully what kind of a planet we travel to. It will be expensive and time-consuming. And I think it's clear we want to go to planets that have some chance of biology on them.
Berkeley professor Jeff Marcy has discovered more exoplanets than anybody else. If you're looking for a new Earth, he's your man.
The first prerequisite for life on a planet is that there has to be a hard surface on which the water can puddle into ponds and lakes.
In our solar system, Earth is unique. It's the only place with liquid water, a breathable atmosphere, and just the right amount of sunshine. Earth sits in what scientists call the Goldilocks zone. Not too hot, not too cold, it's just right. I'm helping Jeff set up a model of a solar system.
Go ahead.
We're using water-filled beakers to represent planets. And liquid nitrogen replicates the coldness of outer space.
Now, we've got to simulate the sun.
We need a sun.
Got one.
Our model solar system has 3 planets. The first is close to its sun.
So, of course, this planet is not only having its water boil, it's evaporating away, and then that water on a real planet would eventually escape.
The second is slightly further away, and the third is miles away from its sun. All 3 planets started out with plenty of water. The planet closest to its sun has lost all of it, whilst the planet furthest away has frozen. But this one is just right. Water is still liquid. Goldilocks would be happy to live here, and so would my pioneers. If the pioneers could find a planet in the Goldilocks zone, it would be far more comfortable than the other planets in our solar system. But even seeing exoplanets from Earth is a massive challenge. They're 1,000,000 times dimmer than their star and give off no light of their own. Fortunately, astronomers here at McDonald Observatory in West Texas are expert in recognizing faraway worlds.
Hello, Barbara.
Barbara MacArthur is going to give me a crash course in exoplanet hunting. First, she gives me a guided tour of the Hobby Eberly telescope, one of the world's most powerful stargazing systems. It's made out of 91 identical mirrors and a tracking device which moves with the rotation of the Earth, allowing a single celestial target to be observed for long periods.
One of the highest points in Texas. It's an amazing view.
For these exoplanet hunters, the trick is to watch the star. When a planet travels around a star, it yanks on it, causing the star to wobble.
Let me just get this straight. So, there's your star that
Right.
you're looking at.
Right.
If there's a planet rotating around it, it's pulling it a little bit.
It tugs it. It tugs it.
So the motion of your star,
Right.
you infer from that that planets are orbiting it.
Right. That planets are tugging it.
Not only can Barbara and her team prove that exoplanets exist, they're even able to work out how far a planet is from its star, calculate the length of a year, and predict temperatures on the surface. But for this telescope to see the wobble of a star, the exoplanet causing it has to be bigger than Earth. For now, the hunt for Earth-like planets continues.
It's amazing because one day we'll find a planet just like Earth that can support life like we can on Earth.
For the first time in our history, we're able to identify worlds outside our solar system that might have all the ingredients for life. For explorers, the most exciting are a group of planets orbiting one of the oldest stars in the universe, Gliese 581. Astronomer Greg Laughlin is an expert on this distant solar system.
The parent star, Gliese 581, is quite a bit dimmer than our sun. It's quite a bit redder than our sun. It's smaller than our sun, and it's about half the temperature.
4 planets orbit Gliese 581: B, C, D, and E. First discovered in 2007, Gliese 581c is one of the smallest exoplanets found so far. With a mass only 5 times bigger than Earth and an orbit lasting 13 days, initial calculations put it in the Goldilocks zone. But Greg Laughlin isn't so sure.
It really is sort of right at the hairy edge of what might possibly be habitable.
The problem is that Gliese 581c is 15 times closer to its star than Earth is to our sun.
The star fills a much larger part of the sky and gives the planet a lot more heat than we get here on Earth.
That makes it too hot for liquid water and my pioneers. You might be able to survive there, but it's not a second Earth.
I personally wouldn't want to be the first person to dive down into the atmosphere of Gliese 581c.
Orbiting further out, Gliese 581d is bigger than C and sits just inside the star's Goldilocks zone. For Greg, it's the best place for my pioneers to start exploring.
If you had to visit one of these planets, then I think that the hands-down choice would be Gliese 581d.
Very little is known about the exoplanets discovered so far, but based on this tiny amount of data, the Gliese 581 system looks like the best place to start looking for a new Earth. But the vast distance isn't the pioneers' only challenge. Just being in space is bad for your health, and we're asking these explorers to spend their whole lives there. One of the biggest problems they'll face is dealing with zero gravity.
Leaving the confines of Earth's 1G environment will have a strange effect on the human body.
Lack of gravity destroys bone and muscle strength. It's a scary thought, but when they land, our pioneers wouldn't even be able to walk off the ship. One solution might be to put them in a spin.
You might ask, why would anybody be interested in rotating at high speeds? Well, that's what's necessary to produce what's called artificial gravity.
Larry Young and his team at MIT have been going round in circles for years.
How's it going? Good. So we've given you a pretty good briefing on this, so you think you're ready to start?
They're designing machines to make artificial gravity, including a prototype that could be flown on future missions.
Right, I'm moving.
This is a short radius centrifuge. It recreates Earth's gravity in space. But to begin with, spinning has a weird effect on my senses.
Now I'm really scared about turning my head. Whoa! It felt like I was tumbling all over the place.
As I speed up, Larry's team reassure me that I'll adapt pretty quickly to the motion.
This is one crazy roller coaster.
I'm spinning at 30 revolutions per minute, and my feet are being pushed against the footrests at 1G.
I can feel quite a lot of pressure on my legs now, like I've got weight in that direction.
The artificial gravity seems to be working. My heart, muscles, and bones are functioning almost as if I'm standing up on Earth.
It's definitely quite an odd sensation.
A daily workout in Larry's gym may beat the damaging effects of zero gravity on short missions,
All the weight is coming off my legs, off my feet.
but my spaceship will be traveling for decades, with hundreds of pioneers on board.
Are you still spinning?
A one-man centrifuge would be impractical.
You can open up your eyes.
Oh my word, I'm stopped.
Interstellar travelers on long missions will need to create artificial gravity throughout the entire vessel. The best solution might be to make the whole spaceship rotate. Like explorers from the past, the crew heads into the unknown, uncertain if their chosen destination can be a second Earth. The captain hesitates. The fate of the crew, and perhaps the human race, is in his hands. Headed for the stars, the crew gets their last ever view of Earth. They will never return. Course is set for their new home. On their way to finding a planet in a distant solar system, our pioneers will have left Earth on a space elevator and will build a ship that can support them on a long voyage. But using conventional rockets would result in a trip of tens of thousands of years. The scale of this expedition is way beyond anything attempted so far, and the pioneers will need to come up with a way to generate enough power for a mammoth mission. Luckily, this is a journey NASA's Les Johnson has been planning for a long time.
I've been thinking about space and space exploration since I was a kid. I'm just thrilled to be able to work on things that might someday enable people to travel to another star.
At NASA Marshall's testing laboratory, work is already underway to develop a groundbreaking propulsion system, a solar sail. It doesn't need to carry onboard fuel like conventional rockets. It runs on a more natural form of energy.
It's a sail, but instead of wind pushing on it, it's sunlight pushing on it. And as light reflects from the sail, it transfers that momentum to the sail and causes it to move through space.
Les's challenge is to create a strong yet lightweight material.
This is a 2.5 micron thick solar sail. Just to give some perspective, that's about 40 times thinner than a human hair.
NASA's high-tech material is not only light, but highly reflective, capable of harnessing the power of the sun. But for an exoplanet mission, it's going to have to be bigger and thinner than anything they've produced so far.
The calculations show you'd have to have something about 10 times lighter than the lightest sail material we've built so far today.
Traveling from New York to Los Angeles would take less than a minute in a solar sail starship. Amazingly, steering these high-tech space sails is just like surfing a kite on Earth. But instead of riding the ocean winds, sunlight pushes on the sail to move it through space.
You can travel for thousands and thousands of miles on the solar wind. Very, very long distances.
That sounds amazing.
And it's basically pretty much the same technique. We're taking momentum out of the wind using these foils.
Right.
In space, you're taking momentum out of the solar wind. And it's free. Free power.
By changing the angle of the kite relative to the wind, it's possible to control my speed and change direction. And it's exactly the same in space.
To speed up, I catch more solar wind by presenting the surface area of the sail towards the sun. If I want to slow down, I spill that wind by changing the angle of my sail.
Our solar sail spacecraft has an endless supply of power from the sun. But the The further my pioneers travel through our solar system and away from the sun, the more energy they lose. Fortunately, Les Johnson's got an idea for keeping the acceleration going.
You would take a laser located in space to continue to shine on the sail and continue to push it, and therefore you'd continue accelerating over a longer and longer period of time.
Adding a huge laser will push speeds to over 18,000 miles per second. That's 1/10 the speed of light. It's a massive advance for our mission. Up to now, sunlight has been good news, propelling our solar sailcraft through space. But the sun is also responsible for hurling radioactive particles out into the solar system.
And that's bad news for my pioneers.
There is one showstopper, I think, for mankind going to other solar systems, and that is the hazard of radiation.
Solar storms are the single biggest threat to deep space travel. Radiation damage in humans builds up over time. The longer the journey, the bigger the problem. I need to come up with a way to shield my crew. On Earth, we're protected by both a thick atmosphere and a magnetic field, repelling many of the harmful particles before they reach us.
This magnetic field extends out into space and actually forms the first barrier, first form of protection for the radiation.
Physicist Ruth Bamford had an idea. She wanted to use this natural phenomenon to shield spacecraft from radiation. A magnetic bubble would protect the occupants, working as a kind of force field. But most scientists thought it would be completely impractical. She designed an experiment to test her idea. A stream of supersonic plasma mimicked the radioactive effect of a solar storm. And a small magnet generated the force field. Amazingly, it worked, creating a magnetic bubble to deflect the radiation, leaving a safe zone in the middle. Scaled up, she believes this really could work for a spaceship.
Without a shield, they just will not survive the trip. And this looks like this might be the answer to it.
Fit Ruth's force field around the spacecraft, and I've got exactly what my pioneers need to survive the mission.
No spacecraft has ever left the solar system until now.
NASA's Ed Stone is a giant of space exploration.
We're headed toward interstellar space where no spacecraft has ever been before. So this is all new, and we're discovering things which we didn't even know that were there to be discovered.
He's in charge of Voyager, the farthest man-made object in space today.
Well, when we launched, the space age itself was only 20 years old, so we really had no basis for believing that a spacecraft could last over 30 years.
Voyagers 1 and 2 left Earth in the late 1970s and are now over 9 billion miles from the Sun. Currently on course for a mysterious barrier at the outer boundary of our solar system. A vast region where hot winds from the Sun meet cold interstellar space. It's known as the heliosheath and has never been crossed by any spacecraft.
Both Voyager 1 and Voyager 2 are now in the heliosheath, this outer layer where the solar wind is slow, and it will probably take on the order of another 5 to 7 years for Voyager 1 to actually cross that sheath and enter interstellar space for the first time.
Voyager 1 will become the first man-made object to leave the solar system. giving my pioneers a much clearer idea of what a mission into interstellar space would be like. Once my pioneers have left our solar system, they're destined for a star called Gliese 581. But I want to know, what are they going to see when they step out of the spaceship? NASA's Nancy Qiang has found a way to predict the color of plants on planets in other solar systems. It turns out that life on an exoplanet would look very different to Earth. Plants adapt to light from the sun, developing pigments that harvest the light they have available for photosynthesis. On Earth, green is the least useful color to plants. They don't need to absorb it, so leaves look green to the eye.
We would expect that photosynthesis might be very successful on another planet, but it might not necessarily look exactly like it does on Earth.
I asked Nancy to investigate what my pioneers might expect to see on planets orbiting Gliese 581. It's what astronomers call an M-type star.
If we were to visit a planet orbiting an M star, it would look something like this. Now, the M star looks very big in the sky because it's much cooler than our sun, so the planet, in order to have a good temperature, must be much closer to the star.
M stars are 50 times dimmer than our sun, emitting mainly invisible infrared light. Plants would use as much of the available visible light as possible for photosynthesis, resulting in some very bizarre-looking foliage.
Plants here could possibly photosynthesize in the near-infrared, but to our eyes, they look black because they'd be trying also to absorb as much of the visible light as they could because it's so scarce.
Nancy Qiang thinks planets orbiting Gliese 581 will be dark, alien worlds. And her calculations mean that I can prepare my pioneers for the environment they'll face when they land. After decades in the wilderness of interstellar space, the pioneering crew finally become the first to arrive at another solar system. So many hopes, but what dangers will they meet? Safely through the heliosheath of a new sun, the space pioneers are on the brink of mankind's greatest adventure, landing on a world that will become the second Earth. We've chosen Gliese 581 based on a minuscule bit of information. Our search is limited by the planet-hunting technology that's available on Earth. But a new telescope has just come online which we can use to identify smaller, more Earth-like planets. It sounds like the sort of technology exoplanet explorers will need on board their craft. David Koch is an astronomer with the Kepler mission. Launched in March 2009, it's NASA's first space-based planet-hunting telescope.
What we really want to find out with Kepler is, are we alone? So you have to find planets similar to Earth in composition. If you want to find ET, you first have to find whether ET has a home.
more than 100,000 stars have been selected as ideal candidates for planet hunting. Kepler's secret weapon is a 95-megapixel camera, the largest ever launched into space. It uses tiny changes in a star's brightness to detect exoplanets. And incorporating it into our mission will help my pioneers search for a new Earth whilst traveling through space. Here's how Kepler works.
Now, what I've got here is our artificial star, and in my hand, I've got an artificial planet, which is going to go in front of the star and obscure some of the light.
As my planet moves across the light, the reading on the light meter drops. Even if we can't see the planet with our naked eye, we can still see its effect on the dial.
When my planet passes this star, the change in light is quite dramatic, as you can see on the intensity meter. But in real life, Kepler is detecting really incredibly minute changes of light.
Kepler technology, for the first time, will be able to find planets similar in size and composition to Earth.
Another Earth. Boy, we can't wait for that discovery to happen.
Space sails may get our pioneers to the stars, but it'll still take up to 200 years to reach Gliese 581. In the distant future, some scientists believe spacecraft will be even more advanced, capable of much higher speeds. This man began plotting a high-speed journey to a star over 30 years ago. His name's Bond, Alan Bond. His goal? To design a vehicle capable of reaching another star within the lifetime of a human being.
The challenge, therefore, was to design a rocket which could actually reach 16% of the speed of light.
That is much faster than a solar sail. A nuclear-powered rocket could be the answer. Exploding mini helium bombs would propel my pioneers to the nearest star in less than 50 years. If I follow Bond's groundbreaking rocket ship, it would be the first step on an epic interstellar journey. We'd colonize space with a multi-generational crew, living inside a structure so vast it's like a city in space.
We'd have to build world ships out in space, in the asteroid belt, and inside that ship we can put an entire population, 250,000 to 1 million people, and within that ship people would just live their ordinary lives as they would on the Earth.
Far in the future, city-sized spacecraft roam the cosmos. When the Earth is gone, mankind will live on. If future generations could make the interstellar crossing whilst living aboard enormous spaceships, travel time wouldn't be a problem.
But perhaps we don't need to travel there physically. Teleportation might be the answer.
I'm on my way to meet a physicist who's bringing this science fiction staple closer to reality. Vlatko Vedril is expert in quantum teleportation. For him, it's the fastest way to cover vast interstellar distances. My pioneers could reach Gliese 581 in 20 years.
And so the idea is, if you could take all the information inside a single atom and then somehow transfer that onto a beam of light, this beam of light would then travel naturally at the speed of light, and you could then accomplish this transfer as fast as it's possible.
For pioneers planning a mission to an exoplanet, traveling at the speed of light is the ultimate solution. This is a teleporter. It's capable of breaking down solid matter into information and sending it somewhere else via beams of light.
So the tricky bit is that even an atom is hugely complex. You have to make sure that all of these million bits of information from a single atom could be transferred across to a beam of light.
In this chamber, an atom is cooled to a very low temperature, blasted with lasers, and encoded as photons.
And that's achieved by shining...
It's taken over 20 years for Vedral and his team to teleport a tiny part of an atom. Teleporting my pioneers is beginning to sound like a very tall order. Successful teleportation requires two machines. One to send information, and the other to receive it. For our mission, we'll need one teleportation station on Earth and one on our exoplanet. A contraption to teleport my pioneers from one point to another is a long way off. For now, beaming up is a pleasure strictly reserved for atoms.
If I was recreated by some other machine which can put every single atom back piece by piece in the correct place,
Yes.
am I the same person?
We'll find that one day when we teleport every bit of information inside every atom in your body, we still are missing some crucial bit. And if this is the case, then I'm afraid you wouldn't probably like to volunteer for this experiment.
Teleportation might work one day. But until then, there are plenty of existing technologies that could take us to the exoplanets. Today, it feels like fantasy, but I'm convinced that one day people really will be able to go.
By finding other planets, especially other Earths, we will surely learn about the frailty, the vulnerabilities of our own Earth.
An expedition to an exoplanet is possible.
There we go.
We're doing it in our imagination now. And I have no doubt that mankind will go out into space and try and visit other solar systems.
We know Earth could become unfit for humans.
So the day will surely come when we'll want to travel to the stars, put colonies there, most of humanity there, on planets elsewhere. For one reason or another, our own survival short-term or survival long-term, we humans must travel to the stars.
Our future is out in intergalactic space. How long do we wait?
This is one crazy roller coaster. Feels so strange. Oh! Look at that.